Hello, Heron and Riverside students. Today we're going to be covering Skill 22, the least common denominators of rational expressions. Let's dig in. So first we want to talk about what is the least common multiple. The definition of a least common multiple is the smallest positive number or expression that is a multiple of two or more numbers or expressions. And what that means is if we're asked to find the least common multiple of something, we're going to think, what is the smallest number that those two things both multiply into or are factors of? For instance, between the numbers 3 and 4, I'm going to list off the things that 3 multiplies to. So 3 multiplies to 3. 3 times 2 is 6. 3 times 3 is 9. 9. And 3 times 4 is 12. 3 times 5 is 15. And 3 times 6 is 18. And then I'm going to list off the things that multiply to 4, right? 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. And 4 times 5 is 20. And then I'm going to look at what do they both multiply to. They both multiply to 12. So the least common multiple of 3 and 4 is 12. So let's think about what is the least common multiple of 3 and 6. Well, 3 multiplies to itself. 3 times 1, 6, 9, and 12. And then 6 multiplies to 6 times itself, 12, 18, 24, right? We want the lowest one, the smallest number. So the smallest number that they have in common is 6. So the least common multiple here is 6. Now if we're using expressions, such as 2x and x, we're going to think, what is the smallest piece of each thing, right? The smallest number or piece that both of them multiply to. So 2x multiplies to 2 times x. And x multiplies x. Those are the smallest pieces of each thing. I am going to take the smallest piece from both things and multiply them together. I'm not going to keep my other x because I'm already using it. So the least common multiple of 2x is 2 times x. So if we're trying to find these inside of a polynomial, we are going to separate or split whatever makes you feel happy, each polynomial into its prime factors. And then we are going to list the separate factors of each prime factorization. Remember, prime means the smallest possible number. And then we're going to use the greatest number of each factor in our least common multiple. So the greatest number of each factor. And then we are going to multiply those factors together, so that we can achieve the lowest common multiple. So, for instance, I want to find the factors of these three things, these three expressions right here. 2a to the third, 6a to the fourth, and b squared. And 4a to the third and b to the fifth. These are three separate expressions. So I'm going to list out the prime factors of each expression. So 2a to the third is the same as 2 times a times a times a. Okay? Can't break it down any farther than that. The prime factors of my second expression are 6 can be broken into 2 and 3. 2 times 3. Both of those are prime factors. Times a times a times a times a. And then I get my b's, b times b. Okay? And then finally I have 4a to the third times b to the fifth, which is equal to 4 can be broken down into two prime factors, 2 times 2, times a times a times a. I have 3 a's, and then 5 b's. B, 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 B. Okay? And now I'm going to use the greatest number of each factor. So I'm going to look at 2's. What is the biggest number of 2's that I have? Well, I have 2 down here, so that is my biggest factor right there. What is the biggest number of 3's that I have? Well, just 1. And then what is the biggest number of a's? I have 1, 2, 3 in my first expression, and then I have 1, 2, 3, 4 in my second one, and 1, 2, 3 in my third. So 4 right here is my biggest piece of A's. So 2 times 2, I'm going to start listing my factors here, times A, times A, times A, times A. Okay, so I'm taking the biggest ones. And then obviously the biggest number of B's that I have is right here. I have 5 B's. Okay, and now I'm going to multiply these factors together. So really I'm just going to put them back together. 2 times 2 is 4, times 3 is 12. A times A times A times A is A to the 4th. And then B times B times B times, oh, that's a D. B times B is B to the 5th. So my least common multiple of these three expressions is 12A to the 4th times B to the 5th. Let's try number 2. I'm going to list out the prime factors of each thing. And see where we meet. So I can list 5 is already a prime factor. It can't be divided any smaller. I can list x squared as x times y. And 25 can be broken into 5 times 5. Oops, put my equal sign there. And then I have 3 x's. And then I have 5 y's. Okay, and now we list the biggest pieces. Most number of least pieces. So I have a 5 times 5 here. So I have 5 times 5 in my LCM. Right here to label it. I have x and x, and then I have 3 x's. So this will be my biggest number of x's. And then my biggest number of y's is right here. And now I'm going to multiply it all together. 5 times 5 is 25. 3 x's are going to multiply to x cubed, and then 5 y's are going to multiply to y to the 5th power. So our least common multiple was actually just our second expression. All right, you guys can go ahead and try a couple of these. Feel free to pause the video. I'll give you a second, and then we'll come back and I will show you the answers. Okay, so for the you try number 3, we have x squared minus 3x, x minus 3, and x. When I break these down, I am thinking about the smallest piece that is still a prime factor. Keep in mind that x minus 3, oops, gone too far there, x minus 3 is a prime factor. I'm treating it as one expression, okay? So x squared minus 3x can be, x can be factored out. That's breaking it down into prime factors. That's exactly what factoring is. X minus 3 is its own prime factor, and then x is its own prime factor. So my least common multiple is the greatest number of each prime factor. I have 1x and 1x, so I'm going to use 1x. And then I have 1x minus 3 and then 1x minus 3. So the greatest number in any expression is an x and an x minus 3, which gives me back x squared minus 3x. In number 4, we have x, x minus 7, and x plus 1. I'm going to tell you right now, these are their own prime factors. These are all prime factors, right? And that means that our least common multiple is going to be an x minus 7, and an x plus 1, which means when we multiply them together, we're going to get x cubed minus 6x squared minus 7x. So I'm going to try number 5, and then I'm going to give you guys a chance to do number 6. So number 5 says multiply x squared minus 9, or not, I'm sorry, find the least common multiple of x squared minus 9, x squared minus 6x, and then, plus 9. So again, I'm going to break these down into their prime factors. Factors should be the hint here. I'm going to factor these, right? X squared minus 9 is a difference of perfect squares, so that's going to factor into x minus 3 and x plus 3. And then x squared minus 6x plus 9 is a trinomial, and I can factor that using an ACB tree or an X-game. The two numbers that multiply to 9 and add to negative 3 are negative 3 and negative 3. This is going to factor to x minus 3 times x minus 3. So now we're going to use our least common multiple. our least common multiple is going to be the greatest number of each prime factor in each expression. So I have 1 x minus 3 and 1 x plus 3. And then I have 2 x minus 3. So I'm going to have an x minus 3, another x minus 3, because that's the greatest number of x minus 3's in the entire list of expressions. And then I have an x plus 3. And then I can multiply these out. That will give me x squared minus 9 times x minus 3, which gives me x to the third minus 3x squared plus 27 minus 9x. And I can rewrite that as a 4-term polynomial. So go ahead and try number 6, and then I will come back and help you walk through it. Okay, so number 6, after factoring both quadratics, you're going to end up with an x plus 2, x plus 1, and an x plus 3 and an x plus 2. Now I want to take the greatest number of each factor. I have 1 x plus 2 in the first one, 1 x plus 1, and an x plus 3 and an x plus 2. So the greatest number of each one of these factors is just 1. I'm going to have an x plus 3, an x plus 2, and an x plus 1. This is the main concept. I am less worried about you guys being able to do this part right here right now. I want you to be able to see which common factors are coming out and which ones make our least common factor. So now we're going to practice remaining fractions to have a particular denominator. So we want to change our denominators in these rational expressions to have a specific denominator. In order to do that, I'm going to find the least, there it is again, the least common multiple, so our LCM that we have been done, of the denominators. I'm only going to deal with the denominators. And I'm going to multiply the numerator and the denominator by my common factors to obtain the least common denominator. Okay? And then I will simplify if it is necessary. Okay? So for number 1, I'm going to think about my denominators right here. List them in prime factors. Right? I'm going to find their least common multiple. So 2x squared, I can write that as 2 times x times x. And then 8x cubed y, I can write as, write it as 2 times 2 times 2, x times x times x times y. Okay? And now I want to think, what is their least common multiple? Their least common multiple is going to be the greatest number of each piece, right here, which just so happens to be my second denominator, right? So the least common multiple is 8x cubed y. And I need to multiply the numerator and denominator by factors that are common to get this 8x cubed y. Well, I don't have to multiply the right side by anything, but I do have to change the left side. And when I do that, I'm going to have to multiply the numerator and denominator. So I am going to think, what do I need to give 2x squared? What is it missing in order to make a least common multiple? Well, I can remove common factors. There's 2 ways to do this. You can think about what factors it needs or what factors are left after you take away. So these both have a 2, an x, and an x. What I have left is 2 times x times y. So what I need to give 2x squared is 4xy. And that makes sense because if I multiply 4xy times 2x squared, I get 8x cubed y. Okay? So now what I'm going to do is multiply the numerator and denominator by 4xy, the thing that I need. I have to do both the numerator and the denominator because that doesn't change my expression. So now I am going to multiply 5 over 2x squared times 4xy over 4xy. They're both multiplying by the same thing because this is just a fraction that reduces to 1. So 5 times 4xy gives me 20 xy. And then we've already decided that 2x squared times 4xy gives me 8x to the third y. So now, using my least common denominator, I have found what my question mark was. So number 1 asked us to find the numerator of this new expression, and we found it. So for number 2, I'm going to repeat the same process. I'm going to look at my denominators right here. 3a cubed b squared c, and then 9a to the fifth b squared c to the fourth. And I'm going to list them in prime factors and find their least common multiple. So I have 3 as its own prime factor. These are a's. I'm going to list them as a times a times a, b squared, b times b, and then c. And then I'm going to have 9, which is 3 times 3, and then a times a times a times a times a, 5 a's, and then b's, so I'm going to have b times b, and then 4 c's, which is c times c times c times c. And now I'm going to look for their least common multiple, which is the greatest number of a's, b's, and c's. Well, again, all of these are my greatest common factors right here. So I have 2 3's, which is the most 3's, 4 a's, or 5 a's, which is the most a's, 2 b's, and 4 c's. So again, I'm going to convert this using just factors of my least common multiple. So I'm going to use the same trick that I used before. I have a 3 up here, so I'm going to take a 3 away. This will tell me what I need to add to 3a cubed b squared c to get an answer. I need 3 a's up here, so I'm going to take 3 a's down here. Or I'm sorry, that means I need 2. I'm going to cancel out my b's. And then I'm going to cancel out 1 c. So what I am left with is 3, 2 a's, so a times a, which is a squared, and 3 c's, which is c cubed. So this is what I need to multiply my numerator and denominator by. So I'm going to multiply my numerator and denominator. I'm just going to write this again right here. By this common denominator. I know that the bottom is going to equal 9a to the fifth, b squared, c to the fourth. And I know that's true because I found their least common multiple and their lowest common denominator. And then I multiply the top. 2 times 3 is 6a squared, c cubed. And that's it, right there. I'm not going to worry about simplifying these yet. I am just going to talk about finding these least common denominators. We will work on simplifying later. So now I want you guys to give these a try. Take a second, freeze the video, and then come back and I will walk you through them. Okay, so for number 3, I am going to split my denominators into least common or small prime factors. X plus 4 is a prime factor. X squared minus 16 is a difference of perfect squares, so I'm going to separate that into its conjugate, which is x minus 4 times x plus 4. And then I am going to look at their least common multiple, which is x minus 4 and x plus 4. That is the greatest number of prime factors in each expression. I know now that I can cancel out x plus 4 and x plus 4 in both expressions, right? So I know that I need to add an x minus 4, multiply an x minus 4, to my numerator and denominator to get a common denominator, the least common denominator. So I'm going to multiply that across. I know that x minus 4 and x plus 4 will give me, that's not right. Oh yes, it is. I'm sorry. X plus 4 times x minus 4 is x squared minus 16, and then 2 times x minus 4 is 2x minus 8. For number 4, I have x minus 3 over, or x plus 1 over x minus 3. X minus 3 is the denominator, so that's what I'm going to factor into prime factors. It's already a prime factor. And I'm looking to move it to x squared minus 6x plus 9. I'm looking to add or multiply something to it to make it that. So after breaking down x squared minus 6x plus 9 into its prime factors, I can see that I have an x minus 3 and an x minus 3. So the least common multiple here, the LCM, is x minus 3 times x minus 3. Sorry, I'm running out of room. Then I'm going to remove the pieces that I already have that they share, x minus 3 and x minus 3. And I'm left with 1x minus 3. So I'm going to multiply my numerator and denominator on the left side by x minus 3. I know that my answer on the right is going to be x squared. The denominator is going to be x squared minus 6x plus 9. X minus 3 times x plus 1 is going to give me x squared minus 2x minus 3. All right, let's try this one. We have x minus 4 over x plus 2. We're converting it to x squared plus 5x plus 6. And we want to find out our numerator. So I'm going to break them down into prime factors. X plus 2 is already a prime factor, so it's not going to change. And then x squared plus 5x plus 6 is going to give me x plus 3 times x plus 2. So my least common multiple is x plus 3 times x plus 2. Greatest number of prime factors I have in each expression. And then I am going to figure out what I need to give my other expression to make it equal. So I want to make x plus 3 equal to x plus 3 times x plus 2. So I'm going to multiply the top and the bottom by x plus 3. X plus 3 times x minus 4 is x squared minus x minus 12. And number 6, I want you guys to give a try and see what you can come up with. So for number 6, we break down our denominators into prime factors. X plus 3 is already a prime factor, so I didn't bother. X squared minus 2x minus 15 breaks down into x minus 5 times x plus 3. Those are the prime factors. They share x plus 3, so what I need to give it is x minus 5. X minus 5 over x minus 5 multiplied the top and bottom gives me x minus 5 times x minus 3. I actually would accept this right here because later on we're going to start canceling our numerator and denominator. But you can also multiply it out and get x squared minus 11x plus 30. Alright, so we are done. Hopefully this video was helpful for you. If you have any other questions, feel free to reach out. Have a great day and enjoy your school.